Hi friends, welcome everyone to Smart Engineering Academy. Myself Amit. I am here with the continuation of WRD Hyderabad Karnataka region question paper analysis. So this is the part 5 of my video. So let us move on with the questions. So in this question they're asking what is quicksand condition? Okay, quicksand condition is, and they have given few options. Before that, let me go into the concept. What is quicksand condition? Quicksand condition is a condition in which, okay, when flow takes place in the upward direction. Okay, in the quicksand condition, what happens? The water which is flowing through the soil will start flowing in the upward direction. Seepage pressure also acts in the upward direction. Of course, when the water started flowing in the upward direction, the seepage pressure will also started acting in the upward direction. Hence, effective stress will be reduced. Effective stress will be equal to stress minus pore water pressure. In this condition, the effective stress is going to get reduced. In such a condition, cohesionless soil mass loses its shear strength and tendency to flow along with the water. Whatever the heap of the soil will be there, it will get dissolved in the water and starts to flow. That is what the quicksand condition is. So quicksand condition is a sand which acts as a quick filter. No, of course. Uniformly graded sand, no, there is no relation. See, a condition when cohesionless soil loses its shear strength due to upward movement of the water. So this is the right answer. This is a very easy and very important question. So if you are thorough with the concept, then it is very easy. Fine. So now let me move on to the next question. Just a second. Yeah. In the next question they have given as the total load carrying capacity in case of total load carrying capacity of an individual frictional pile is 200 kilonewton. So individual frictional pile, that is, will be 200 kilonewton. Then the total load carrying capacity of the group C. Then the total load carrying capacity of group of a such pile with a group efficiency factor. They have given the group efficiency factor is 0.80. This is ultimately a wrong question. See, the same question has been repeated in the same paper. It was already, I have been analyzed the same question. In this, what they have done, capacity of 9 such pile it should be. Okay, instead of 9 they have given it as A. Of course, this is 100%. You will get a grace marks. Same type of question is been repeated twice in the same paper, where in this question they have given, instead of 9 they have given it as A. If you want to do with respect to that, it is very simple. Then if I put the formula, which is equal to QUG, group carrying capacity of the pile divided by numbers into individual carrying capacity of that pile, QUP. If you want to find the QUG, will be equal to, what is N? N is not given. N should be 9, and this is 0.8, 200. It will be 1440 kilonewton. Okay, that is what the question has been wrong in this question. Fine. Next question. It is also a question from geotechnical engineering, very important and very analytical based question. I will explain it in a very detailed manner. See, a constant head permeability test. In this constant head permeability test, they have given was carried out in a cylinder sample of a sand of diameter. Okay, diameter is given, which is 10 centimeter, and height is given, which is 15 centimeter, and volume is given 160 meter cube of water is collected in a time of 1.7 minutes under a head. Okay, under a head of 30 centimeter. They are asking us to find what is the coefficient of permeability, that is K. See, if you find with the help of these formulas, of course, all the 4 answers which is given in the option is wrong. This is also a one more grace question. I'll just explain you how to solve this question. It is very simple. See, with the help of this data, I can calculate the value of Q. Q is equal to V by T, where V, what is the value? V is equal to 160 meter cube and T is 1.7, which is in terms of meter cube per minute. Head is given as 30 centimeter. Now I'll directly put the formula where Q is equal to KIA, which is also will be equal to V by T. Okay, by making use of this equation, you can find the value of K, where after substituting the value, all the values is already been given. After substituting the value of K, you are going to get it as 314,924.56 into 10 power 4 meter per year, because in the question they have asked in the meter per year. So of course these 4 are wrong answer. Be happy, still you are getting a grace answer for this question. Fine, let me move on to the next question. This question is very important and very easy from CPM and PART. It is a direct question. The project expected to take how many months? 15 months along the critical path, having a standard deviation. The value of standard deviation is they have given as 3 months. Permeability factor Z for the completion of the project within 18 months. Very simple. 18 minus 15 by 3, which is equal to 3 by 3. 1 is the answer, direct answer. This is again, the question is from CPM and PART. If you know the concept of CPM and PART, you can easily answer the question. The time when an event, okay, can be expected to occur is nothing but earliest expected time. Latest allowable time, it is optimistic, most likely it is of different concept. The time of event which can be expected to occur is nothing but earliest expected time. The minimum distance between the 2 rails of the broad gauge track in India. There are 3 concepts we need to find here. This comes in railway engineering, which corresponds to transportation engineering. Broad gauge track as a gauge of 1.676 meters. That is nothing but 1676 mm. In the same way, meter gauge will be 1 meter, and narrow gauge, please do comment in the comment section. Fine. One more very important and very beautiful question from geotechnical engineering topic. Listen carefully. I am going to do the detailed analysis of this question. Fine. So these type of questions, it is little time consuming in the examination. So keep these type of questions after after solving all the questions, keep this type of question in the last, because if you are going on solve this question, it takes lots of time. Sometimes you may lose the time also. These type of bigger questions you need to solve at the last after completing all the direct questions. So an embankment of height 2 meter. Let me write draw the embankment here. Height of the embankment is given it as 2 meters, and width at the top is also 2 meters, with a side slope 1:1. Side slope is given 1:1. Okay, so what I will do, 1:1. If it is 1:1, this will also come 2, this will also come 2. Okay, just some geometrical constants. And it has a bulk unit weight of this embankment as a bulk unit weight. I'll just take it as gamma B1, bulk unit weight of 18 kilonewton per meter cube at a water content, at a water content 10%, which you can also be written it as 0.1. If the water content is to be increased in the same embankment, let me take it as W1. If the water content need to be increased for 14%, that is nothing but 0.14, without changing the void ratio, that is void ratio is same in both the condition, the quantity of water required to be added. Okay, what is the quantity of water required to be added in order to increasing the void ratio, increasing the water content, keeping the void ratio same in both the cases. What is the water content we need to add? That is the main motto that we need to find out here. And the length of the embankment is given. The length of the embankment will be equal to 2 meters. By making use of this, I can find the volume of the embankment. Volume of the embankment will be equal to 2 into 2 plus again this area will be 2 plus 2. So total length of the embankment is 2. So the volume you will get it as 16 meter cube. Okay, this is first thing. Next, next what I need to find, see, weight will be equal to total weight divided by 1 plus water content W1. This water content W1 which is equal to again total weight in the second condition. This is in the first condition, and total weight in terms of second condition when the water content is being increased, that is 1 plus W2. And we know the formula gamma bulk, that is bulk unit weight will be equal to weight, total weight per volume. Simple. So weight will be equal to gamma bulk into volume. This weight will be equal to gamma bulk 1 I will take into total volume divided by 1 plus W1, which is equal to gamma bulk 2 into total volume divided by 1 plus W2. See, volume is constant because the embankment is constant. The only thing we are changing here is water content, and being the void ratio same, what I will do, what is the gamma bulk 1? It is already given in the question, that is 18 kilonewton per meter cube. 18 into the total volume will be 16 divided by 1 plus W1. What is the water content at the initially it was 0.1, and later I don't know what is gamma bulk 2 into 16 divided by what is the water content. Water content will be 0.14 in the second condition, which is increased to 14%. So by making use of this equation, I can find the value of gamma bulk 2 value. You will get it as just a sec. Okay, 18.65 kilonewton per meter cube. So then I need to find the weight. Gamma bulk 2 is equal to weight per volume, where weight is equal to gamma bulk 2 this is 18.65, don't mind, 18.65 into 16, you will get it as 298.47 kilonewton kilonewton weight. Now, so this is the change in weight. So what was the initial weight? Initial weight will be weight, I'll just tell you, initial weight will be volume 16 into 18 bulk unit weight, which would be how much? Yeah, just a sec. It will be 288. Okay, so what is the difference in weights? The difference in weights, if you calculate, it will come as 1.067 in terms of meter cube. You need to convert it into the meter cube. So the answer will be 1.067 or 1.068 meter cube. Again, next one beautiful question from geotechnical engineering topic, that is what is consistency index. So let me read out the options. The numerical difference, they're asking the numerical difference between liquid limit WL and plastic limit WP is nothing but plasticity index. Okay, plasticity index, this is the option. Next is asking the ratio of natural water content minus plastic limit WP to the plasticity index IP. This will be equal to liquidity index, which can be represented in terms of IL. Again, the ratio of liquid limit WL minus natural water content divided by IP plasticity index, it will be equal to IC is nothing but the consistency index. So option 3 would be the right answer for this question. The ratio of IP, plasticity index, divided by flow index, IF, will be equal to activity number. See, these 4 concepts we came to know, but according to this question, the third option is the right question. Right answer. So next question, very easy question. So question is little blur here, don't mind, I will tell you the data. Quantity of water flowing through the filter arrangement shown in the figure is, so we need to find the quantity of water which is flowing here. So quantity of water flowing here, we can put the formula where Q is equal to KIA. In the question here they have given the coefficient of permeability. The coefficient of permeability is 1 into 10 power minus 5, and dia is given which is equal to 2 meters. 2 meters is given, and we can find the value of Q. What is the K? Value of K is equal to 1 into 10 power minus 5. I is nothing but I is equal to H by L. H we already know, we can see from the figure, which is equal to 5 divided by length is 2.80 meter into area. Area is pi by 4 into d square. I will convert this d in terms of centimeter, which will be equal to 200 square. You will get the answer as 0.560 centimeter cube per second into 10 power minus 6. If you convert it into the meter cube, it will become 5.61 into 10 power minus 7 meter cube per second. Next, once again, and very important and analytical based question from geotechnical engineering. This I will make a understanding analysis for this question. A specimen of, see, this type of questions you keep it in the last after solving all the simple questions. This is a simple question, but the data is more. While doing, if you want to do it initially in the starting of the examination, there comes a condition that you may be stuck in between and you may lose your time. So time management is most important in the examination hall with respect to the preparation. The art of solving MCQs, the art of solving the question paper comes into very important role, that comes by taking the mock test before the examinations. Okay, fine, let me read out. Specimen of hard clay with a diameter, okay, diameter is given in this question. Okay, the specimen of the hard clay of diameter is 0.06 meter fails under an axial load of 0.17 kilo Newton. I'm sorry, unified in a unified compressive test. So in the unified compressive test is given UCS, I will take it as 0.75 divided by area in terms of kilonewton, because stress is equal to load per area. So I am directly converting it in terms of unified compressive strength. The load I am getting convert. So P is load, don't get confused, 0.75 kilonewton. I am just converting it in terms of UCS, which you can also return it as sigma. Then diameter is given, diameter will be equal to 0.06 meters. The failure angle pi will be equal to 30 degrees with the axis of the specimen. The lateral pressure in the cell required for the failure to occur for a similar sample which is tested in a triaxial test. See, unified compressive strength test is the first condition. The same sample we are seeing in the triaxial test, in which they have given the deviated stress in terms of this will be equal to 300 kilonewton per meter square. So let me find out in the first condition, that is unified compression test, that is, see, it is given like this. if this is the neutral axis and if I take this as a theta c and stress is acting in this point, so for major principal plane this would be the major principal plane because the stress is acting upon this directly in the perpendicular direction. So now I can find the value of theta c. Theta c will be equal to 90 degree minus 30 degree will be equal to 60 degree. Now unified compressive strength test will be equal to 2c tan theta c, where already I know what is the value of UCS. UCS will be equal to 0.75 divided by area, which is equal to 2c into tan. What is the theta c? The theta c value will be 60 degree, and c will be equal to 0.75 divided by 2 root 3 into area. This is with respect to unconfined compression test. Next, in case of triaxial test, I am moving on. With respect to the triaxial test, we know the formula sigma 1 is equal to sigma deviated stress plus cell pressure. It can also be written it as deviated stress plus sigma 3, where sigma 1 is equal to sigma 3 tan square theta c, the value of theta c already we know, plus sigma cell pressure, that this will be equal to 2c tan theta c, which is equal to 2c tan theta c. If you substitute the value in this, okay, and we know sigma 1 will all, it is also called as deviated stress plus cell pressure, where sigma 1 I will write it as sigma d plus sigma 3. Sigma 3 is nothing but sigma cell pressure, then sigma 3 tan square, what is 60 degree plus 2c tan will be of already we know the value of c. What I will do here, 2 into c. What is the value of c? 0.75 divided by 2 root 3 into a into tan 60 degree. If you substitute this, the value of deviated stress is already you know, which is 300 kilonewton per meter square. I am not going to show all the calculation. Okay, just I will take, if you substitute this value, sigma 3 will become 17.37 kilonewton per meter square. This is easy question, but it requires some time, so the answer would be 17.37 kilonewton per meter square. Okay, that's all guys. Remaining questions I will take in the next lecture series. Thank you and all. Bye bye. If any queries is there, please do comment in the comment section.